Welcome to the Corf Tutorials. Today, we will show you how to size pumps and the associated instrumentation. Let's start with a simple system containing an atmospheric tank, a pump, and a control valve. The process conditions established that we must deliver 100,000 kilograms per hour of material from the atmospheric tank, F1, to a destination, TK1, at a minimum pressure of 300 kilopascals. Additionally, the design guidelines require control valves to have at least 70 kilopascals of pressure drop during normal operation. Double-click on the first branch segment, L1, go to the Flows tab, and specify a flow of 100,000 kilograms per hour. Then, go to the Pipe tab, and remove the default pipe size to let Corf estimate the proper diameter, and change the length to 5 meters. Finally, click on the Sizing button and specify a maximum pressure drop to 10 kilopascals per 100 meters. Click OK to exit the sizing dialog, and OK again to save changes. Go to the third pipe segment L3 and remove the size, then change the length to 5 meters. Click OK. Finally, remove the size from the second segment while maintaining the default length. This means that the control valve is located physically close to the destination tank TK1. Double-click on the source, F1, and specify 0 for the feed pressure. Change the type to tank, the fluid level to 1 meter, and click OK. Next, double-click on the product TK1 and specify a pressure of 300 kilopascals. Keep all the other parameters as default, and click OK. Then double-click on the pump and remove the pressure drop specification, as this is the value that we would like Corf to calculate. Double-click on the control valve and remove the size information, CV and opening. Instead, add 70 kilopascals as pressure drop and click OK. At this point, the specified variables should match the requirements, left bottom corner, and you can run the simulation. Click on Hydraulics, and after a few iterations, Corf will find a solution for this system. Click on the Results button and display flow, equipment pressure, valve pressure drop, and pump NPSH. Click OK. Open the pump and you will notice that Corf not only estimate the required pressure increase to meet the process requirements, but also the efficiency, the required NPSH, and the shoot-off pressure. Let's estimate the NPSH available and compare against the required. Go to the NPSH tab and select F1 as the tank source. The vapor pressure credit corresponds to the difference between the suction vessel pressure and the liquid saturation pressure. For this exercise, assume that the liquid is water at 25 degrees Celsius. Vapor pressure is approximately 3 kilopascals. And therefore the credit that we have is about 98 kilopascals. Click OK, and run the simulation again. Once Corf finds the solution, open the pump dialog, and review the NPSH available. We can verify if it is higher than that required, and therefore our pump would operate just fine. Corf also provides the ability to generate typical curves based on the current flow, head, efficiency, and NPSHR. This can be done manually, or every time case 1 is run. Let's explore each one. First, open the pump dialog and go to the second tab, Curves, and click on Generate Typical Curve now. Confirm the override warning, and you will notice that Corf provided inputs for flow, head, efficiency, and NPSHR that are consistent with the pressure increase calculated for the system. Please note that shape of the initial pump curve can be updated if required via the project files. The second option allows you to generate new curves after case 1 is run, by selecting Generate Curve each time for case 1. This is particularly useful if you are making changes to the model or updating specifications, and want to create a new curve after each run. Values for the default curve can be overwritten. Let's assume that the pump manufacturers indicate that pumps suitable for this application usually require NPSHR of at least 6 meters, which is higher than the value estimated. We can provide that input to Corf by moving to the Pump NPSH tab and adding 6 as NPSH required. Click OK to save. Run the simulation again. You will notice that on top of the typical case iteration information, now the solution log shows a new statement regarding the pump curve. Click OK and visit the pump. As you can see, the new curve was generated considering the NPSH requirement for the current operating case. At this point, we could make other changes in the simulation, like updating the product pressure or changing control valve pressure drop, and every time the case 1 is run, Corf will update the curve accordingly. However, let's try another feature and use the generated pump curve for other cases. Let's assume that we would like to know the control valve pressure drop change when the flow is reduced. A simple analysis would suggest that lower flows would have result in higher pump heads, and therefore our control valve would require a higher pressure drop to maintain the product required pressure. To verify our analysis, go to Hydraulic Cases and change the second case description to minimum. As we didn't change anything from the original simulation, there is no need to run the case 1, so only use 2. Click OK to accept changes. Double-click on the first pipe and move to the Flows tab. Add 60,000 as flow specification for the second case. Make sure to enter a semicolon to separate each case specification. Click OK to save. Open the pump and add a C for the pressure drop to instruct Corf to use the generated curve. Once again, ensure that you are adding a semicolon for the first case. Finally, go to the control valve and add a semicolon after the current pressure drop specification to indicate that we want Corf to calculate the pressure drop for the second case. Click OK and rerun the simulation. After a few iterations, Corf will find a solution for the new system. As expected, the reduced flow resulted in higher pressure across the pump, based on the generated curve, and the control valve pressure drop doubled to maintain the product required pressure. Finally, note that instead of generating a curve, we could copy and paste real values from an actual curve provided by a vendor. Just don't forget to uncheck the option to generate curves with case 1, so it doesn't get overwritten. Congratulations! Now you know how to calculate pumps, create pump curves, and use pump curves in Corf.